So we have been talking about great features of EXTREVA ASE, all the components and how it works, but let's dig now into PFAS analysis and the US EPA Method 1633A. I have a question for you, Ed. What is the US EPA Method 1633A and why is so important?
Okay, it's a very important method. This method was developed by the EPA Office of Water in conjunction with the Department of Defense, right? Okay. And so what they wanted to do was they wanted to address other matrices besides water samples.
Right.
So in the current regulations, the EPA is beginning to regulate municipal water supplies, drinking water, using methods called EPA Method 533 and Method 537. And they are targeted only for very clean drinking water samples that come from these processing systems. So what the Department of Defense decided to do was they needed to look at how do we clean up sites that are contaminated with PFAS. So as you can imagine, you know, PFAS is basically contaminating everywhere. And one of the biggest problems is these wastewater treatment plants have generated a lot of these sludges and other types of materials. It's been applied to land and it's been getting all over the place, right? And so, and we didn't know about it, right, over the years. And as a result, we need to be able to test other matrices. And so EPA 1633 was designed to look at matrices such as soils, biosolids, also non-drinking water samples and tissue samples. Right. Because PFAS is pretty much getting everywhere. And so the method is really designed to look at a target list of PFAS, around 40 compounds, by LC-MS-MS. It's a technology to detect the PFAS at a very low concentration. And this is very important because when these sites are cleaned up, they're going to have a standard method to use. And so this is a regulatory compliance method. And so this is a very important milestone to have a common method that can be used across these sites so that the data is comparable. And that's very important, right? And so that's why a compliance method is very important for situations where data is going to be compared site to site, because if you use your own method, right, the EPA is afraid that they could give different results depending on how the extraction took place.
We're standardizing across the entire nation.
Correct, and that was really important for EXTREVA ASE to work with the EPA, with the system. I should say that it was important for the EPA to work with this automated extraction system, the EXTREVA ASE, to use it to make sure it is very similar or compares directly to, I should say, I'm saying it wrong, but it should compare directly to the method as written. So the method as written is a manual process, right? It's a manual extraction and cleanup, which is very laborious. This process uses the dynamic gas-assisted extraction, which is much more efficient, as we mentioned earlier, but it also is giving the same results as a manual extraction. And that's what we had to show working with the EPA as we developed the method.
So for the audience, you mentioned two methods, the 533 and the 537. How does 1633A compares to those two methods in terms of the target analytes compare?
Yeah, the target analytes in method 1633 are larger. There's about 40 compounds, and they're about half the number of analytes that are in the other two methods. And the other two methods, again, are aimed at drinking water, and they involve a solid phase extraction as well. Right. And for the most part, it's a pretty manual process, right? So, whereas 1633 really starts to break out and look at other matrices. So as you can imagine, even non-drinking water samples have a lot of particulates in them, there's sediments in them, they're sort of biphasic samples. And so 1633 addresses that problem by having you separate those phases, where you extract the water sample and you extract the soil sample. So the EXTREVA ASE is designed for the solid samples. So that's really what we want to say here. It's designed for the solid samples and makes that process easier. Otherwise, you have to do two steps manually, which is very difficult and takes a lot of labor.
So if I understand correctly, the samples with EXTREVA ASE for 1633A method do not need to be dry. So we could deal with even semi-solids, or sort of like, I understand it's not intended for water samples, but it could be used for kind of like smushy, like wet samples?
Yeah, it can be, and I believe the method actually has you calculate the percent moisture in the samples. And so the method's really clear on how you handle those kinds of samples. Okay. And of course, if you have a biphasic sample, so say you have a sample with a bunch of water on top and a big bucket of sediment at the bottom, that's two samples. So you extract the water sample, and then you'll extract the sediment sample with the EXTREVA ASE.
Correct. Perfect. So kind of like to summarize, two of the key difference of this method would be the analysis of a variety of samples that were not covered by previous methods, and an amplification of the target analyte scope.
Correct.
Perfect.
Absolutely.
Awesome. Thank you, Ed, for your insights.